Today, we're diving into something that sounds like it's straight out of a sci-fi movie, but it's actually a fundamental law of our universe. We're going to break down why time isn't what you think it is, and how just moving around can literally slow it down for you. Let's get into it. All right, our journey begins with a pretty major crack in our everyday picture of reality. We all kind of feel like time is this constant river, right? Ticking forward at the exact same rate for everybody. But what if I told you that's completely wrong? Yeah, you heard me. The rate that you personally experience time actually depends on how fast you're moving. So every second that ticks by for you, it might be a tiny bit longer or shorter than a second for someone else. And this isn't some philosophical metaphor. This is a hard physical fact of our universe. Which, of course, brings up the big question. How is that even possible? It seems to defy all logic. How can something as basic as time be flexible? Well, the answer isn't in our clocks. It's in the very fabric of the cosmos itself. And it all kicks off with one single, unbreakable rule. To really get why time bends, we first have to understand the one thing in the universe that absolutely refuses to. This right here is the key that unlocks the whole mystery. You can think of it as the ultimate cosmic speed limit. The truly wild thing about the speed of light isn't just the number. It's the fact that its speed is absolute. It's the same for everyone, everywhere, all the time, no matter how fast they're moving. And this one deeply strange fact is where our whole understanding of reality starts to get really interesting. Look, in our normal lives, speeds add up. If you're on a train and you throw a ball forward, someone on the ground sees the ball's speed as the train's speed plus your throw. Simple. But light just doesn't play by those rules. Shine a flashlight on that same train, and both you and the person on the ground will measure that light moving at the exact same speed. It's just bizarre. And because the speed of light refuses to change, the universe is forced to change something else. Something else has to give. So, to see what actually gives, we can use this brilliant thought experiment that Einstein came up with. It's called the light clock, and it's the perfect way to see why this cosmic speed limit has such a crazy effect on time. So let's build this thing together, right in our heads. All you need are two mirrors and a single particle of light. That's it. It's the simplest clock you could possibly imagine, but it's about to show us one of the deepest truths about how everything works. Okay, so follow me here. We've got a little particle of light, a photon, just bouncing up and down between two mirrors. Tick, tock. Super simple. Now, from your perspective, if you're on a train with this clock, you just see the light going straight up, straight down, a short vertical line. But for someone standing on the ground watching your train fly by, they see something different. They see that photon traveling a much longer diagonal path because it has to catch up to the moving mirrors. And this is the aha moment. Remember that cosmic speed limit? The speed of that photon is the same for you on the train and for the observer on the ground. So, here's the crucial part. If the photon has to travel a longer distance for the outside observer, but it can't go any faster, what's the only possibility? It must take more time to make the trip. So each tick of that moving clock actually takes longer to happen from the stationary point of view. And since our clock is made of the most fundamental stuff in the universe, light and space, it's not just the clock that's slow, it's time itself. For that moving clock, time is literally passing more slowly. Now let's take this pretty mind-bending idea and see how it's not just a theory, but a hard engineering reality that you probably use every single day.
It's really easy to just write this off as some weird theoretical physics thing, you know? But is there any proof that this actually happens out here in the real world? The answer is a huge, resounding yes.
That's right. Every single time you pull up a map on your phone, you are using a global network of satellites, and that entire system would be completely and totally useless if it didn't constantly correct for the effects of time slowing down. So because those GPS satellites are orbiting Earth at about 14,000 kilometers per hour, their clocks on board actually run a tiny bit slower than our clocks down here. Now, you combine that with the effects of gravity, that's a whole other explainer, and their clocks get out of sync with ours by about 38,000 nanoseconds every single day. 38,000 nanoseconds doesn't sound like a lot, but light moves incredibly fast. That tiny little time difference would cause your location to be wrong by about 10 kilometers. That's over 6 miles every day. Your phone's map would be useless in a matter of hours. So every time you use GPS, you're using technology that has to rely on the fact that time moves slower for moving things. And GPS is far from the only proof. Scientists see this constantly in particle accelerators, where particles moving near the speed of light last way longer than they should. They've proven it by flying super precise atomic clocks on jet planes, and then comparing them to identical clocks left on the ground. Every single time, the theory holds up perfectly. So, what does this all mean for you, personally? Well, it means we kind of have to rethink our place in the universe. It's not just about moving through space anymore, it's about our journey through something much, much bigger. The ultimate realization here is that space and time are not separate stages where stuff happens. They're fundamentally linked. They're woven together into a single, four-dimensional fabric that we call space-time. And here's the thing, you can't just move through space. You are always, constantly traveling through space-time. Think of it like you have a speed budget. Every object in the universe is always moving through space-time at a fixed rate, the speed of light. So here's the big takeaway. When you're sitting perfectly still, you're using your entire speed budget to travel through time. But when you start to move through space, you have to use some of that budget on spatial movement, which means there's less left over for moving through time. This leads to the ultimate conclusion. The faster you move through space, the slower you have to move through time. So the next time you're on a plane or even just jogging down the street, remember this. You are subtly changing your personal rate of time. Compared to somebody sitting still, your own personal clock is ticking just a tiny, tiny bit slower. The effect is minuscule in our day-to-day lives, sure, but it is absolutely real. And it leaves us with this incredible thought. Your personal timeline is unique. It's forged by your every single movement through the universe.